Okay, today we are going to learn linear search. Now, you already know what is searching. Searching means that here there is a list of elements are there and we are searching a particular element within the list. Now, what is linear search? Now, the linear search is a kind of search where the element that is search, this element is also known as the key element. The element that we are going to search within the list is called the key element. Okay, so this is our key element. Now in case of linear search, the key element is compared with all the elements within the list, but one after another, starting from the very beginning. So what I mean to say, that suppose this is your key element. Now this key element is compared, you have to compare this key element with the first element of the array. If the key element is not found at the first position, suppose if your key element is 60, now you see that 60 is not found at the first position. Then if it is not found, then the key element you have to compare with the next element of the array. That is the second position is a of 1. And again, if the key element is not found here, then again you have to move to the next position, that is a of 2. And again you have to compare the key element with the next position. And this way you have to continue. So how long the process will continue? Unless and until you are getting the key element, you are getting this key element in a particular position, or you are comparing with all the elements within the list and you are not getting the key element. That is for unsuccessful search. So unsuccessful search means that you are comparing all the elements in the list by key element, but you are not getting your result. This is called the unsuccessful search. Now, in case of here in this program or in this searching method, we are considering this list of elements. So here I am considering that the n value is 5. So you can see that in this list there are 5 elements are there. So 20, 60, 35, 40 and 50. These are our list of elements are there, and I have already written their index. Okay. Now in this linear search, we are considering two variables. One variable is a flag variable. Now what is flag variable? You already know the flag variable is basically a decision making variable. It is a decision making variable. So after comparing the key element with all the elements within the list, now you have to check what is the flag value. Now flag value, here the initial value is 0. Now if you, after comparing, if you see the flag value is 1, that means that the key element is found in the list. And after comparing, if you see the flag value is 0, that means that key element is not found within the list. Okay, so here we are considering the flag value is, initial value of flag is 0, right? Now I have already told we need one more variable. It is called the key element, the element that you have to be searched within the list. So this is called the key element. Now in case of linear search, what I have already told, that you have to compare this key element with the first element of the array. So you see we are comparing the first element, you know already, it is a of 0, index value is 0. So a0 will be compared with the key. Now if there will be two cases, you see that one is that you are getting, the key element is found at the first position. Now if it is found, so this case will be considered. If the key element is found at the first position, so you have to move to this case. So what we will do, as the key element is found, key element is matched with the first position. Now I have already told the flag value, you have to initialize the flag value with 1. Now where the element is found, what is the index of this position? The index position is 0. So POS indicates the index. So POS value is 0, and as you already know that key element is present in the list and it is present at the very first position of the array, so you don't need to compare key element with the rest of the elements. What I mean to say, suppose your key element is 20, right? Now your key element is 20, the first element of the array is also 20. Now when you compare with the key with the first position of the array, at the very first case the key element is found, key element is matched with the first position. So why we will compare once the key element is found at the first position, we don't need to compare the key with the rest of the elements of the array, right? So that's why I have written here, you see that I have written break. So break means that you don't need to compare anymore. Okay, once the key element is found, you don't need to compare with any more elements of the array, right? Now if it is not found, that reverse case. Now if the key element is not found at the first position, so what we will do, as I have told, it is called the linear search. So linear search means if it is not found at the first position, now your next task will be, now you have to compare the key element with the next position of the array. So next position is A1. Now key will be compared with A1. Here also there will be a two situation will arise, two cases will arise. One is equal to, another is not equal to. Now if the equal to, so equal to means that what will be your flag value? Flag value will be 1, as it indicates that search is successful. Now what will be the position in this situation? What will be the position where the key element is found? The key element is found at which position? 1 position, right? So the POS will be initialized with 1, and again you don't need to compare with the rest of the elements of the array, right? Now if it is not found, then the key will be compared with the next element of the array, that is A2. Now again there will be a two cases, so equal to and the not equal to. If equal to, then the flag value will be 1 and the POS value will be 2. Now the position is 2 and break. And if it is not found, then key will be compared with A of 3. So this way the process will continue, right? Now if you see the advantages, right? The first advantage is, see the linear search. If you look at the linear search, it is a very simplest technique, right? Very easiest technique to search one element within a list. Why it is simplest? You can easily understand the process itself become very simplest, right? Now the case is that you have to compare the key element with the first position of the array. If it is found, then very good. If it is not found, then the key will be compared with the next position of the array. If it is found, then also it's good. If it is not found, then the key element will be compared with the next position of the array. So this way the process will continue, right? So that's why I'm telling that simplest technique to search an element, right? Now again, in case of linear search, it's not mandatory or it's not necessary actually that the array list should be in sorted order. Why the sorted array is not required here? Because you see that always whenever you will search one element within a list by using linear search, you have to always compare the key element with the first position of the array, then next position, then third position, then fourth position, so on, right? So in this situation you don't need to require a sorted array, right? So linear search, you can say that linear search is applicable for both sorted and the unsorted array, right? And again, not affected by insertion and deletion. What that means, that suppose in an existing list, right, in an existing list, if you add one new element, or from an existing list if you delete one element from the array, it does not matter for the linear search. So if you add one more element within a list, or if you delete one element from the existing list, it doesn't matter. It doesn't matter for linear search. Okay, so in that case also the linear search will work, right? Now the disadvantage is you see it is written that it is a slow searching method for large array. Why I am telling that, if just think about it, that suppose the array containing a large number of elements, maybe 400, the array contains 400 elements, and suppose the key element that you need to find out, the key element is present at the last position of the array, so in that case, how many elements you have to, how many iteration you require? You require you have to, if the key element is present at the last position. So what you have to do? You have to compare all the elements of the array. You have to compare with the first, then second, then third, so on, unless and until you are comparing the key element with the last position. So in case of linear search, it is very lengthy process and the time consuming process for the large size of array, right? Now the second disadvantage is, if the key matches with the last element, or if the key is not present in the list, then all elements need to be compared. Obviously, if your key element is present at the last position, if the key element is present at the last position, or another case, if the key element is not present at all in the list, then also you have to compare all the elements of the list, right? You have to compare all the elements of the list. Unless and until you will compare all the elements with the key elements, you cannot make a decision that key is not present in the list, right? So in case of linear search, so this is the worst case. You can say this is the worst case of the linear search, that when the key element is present at the last position, or if the key element is not present at all in the array, in both two cases you need to compare all the elements with the key elements. Now move to the program code, right? Now I am showing you the program. Just you see the program is here. Now as I have told that you need two variable, one is flag variable, another one is POS variable. So initial value of flag will be a 0. It is a decision making variable. Once the key element is found at any particular position, the flag becomes 1, and POS initial value is 0. Now you have to compare key with the first position of the array, then second, then third, so on till the last index. So here we are considering the array containing the n number of elements. So for n number of elements, you know already the first index will be 0 and the last index will be n minus 1. So the loop will be 0 to less than n I plus plus, right? So this is the index loop. So now we are comparing if a of I is equal to key. So when I equals to 0, that means you are comparing key with a of 0. Now when after this one, if the key element is not found at the first position, though automatically the I becomes 1, now the key will be compared with a of 1, and again the key is not found at the second position, that is a of 1, then again the I will be increased and key will be compared with a of 2, so on, right? So if a of I is equal to key, then flag becomes 1. Now what will be your position? The position will be I, because the key is found at which position? I position, right? That particular I position, and as once it is found, you don't need to compare key with the rest of the elements. So that's why I have written here break. So after this loop, we will simply going to check that what is your flag value. Now if flag value is 1, you see that once the key is found at particular position, once this condition is satisfied, what is your flag value? The flag becomes 1, right? So after flag equals to 1, if flag equals to 1, then system.out.println that search is successful and the key is found at position POS, and if the flag is not 1, that is else part, that is flag becomes 0, right? So search is unsuccessful. So this is all about linear search.